All right, in question 2 of lesson 5, we're going to apply Bayes' rule. Bayes' rule is a way you get a conditional probability from other conditional probabilities, related conditional probabilities, and marginal probabilities. Okay. Now, in this example, a life insurance company, it issues standard or premium policies. A standard policy is sold for $13.50. Your number will vary from mine. And a primary policy is sold for $25.50. The dollar value of the benefit of the standard policy is $9,010. And the dollar value of the premier policy is $25,600. 60.2% of policyholders have the company's standard policy, and the company has 182,000 policyholders. Historical data indicates that 16.57% of policyholders die within a year of purchasing their policies, and 8.43% of premier policyholders die within a year of purchasing their policies. Now, we're going to solve this problem using this template I created. Okay, this template is kind of an introduction to spreadsheet modeling. So I'm not going to have you build the model. I'm going to have you use this template. And what you want to do is you want to download it here, and then you're going to copy the template into your Excel labs parentheses lessons.xlsx file, right? Okay, so let's download it. There it is. I'm going to open it up. Okay, there it is. Let's start filling in our model here. The gray boxes are inputs to the model. The standard policy is sold for $13.50. The cost to the insured is $13.50, right? And a premier policy is sold for $25.50 in my model. So this is the cost to the insured, right? The dollar value of the benefit of the standard policy is $9,010 in my model. And the dollar value of the premium policy is $25,600. So what this is basically going to cover funeral expenses, right? Okay, so that's it for those 4 inputs. Let's do the inputs over here, right? So now we got 60.2% of policyholders have the company's standard policy. Notice I'm copying the number and the percent symbol policies. We're going to put that right here. Okay. And then the company has 182,000 policyholders. So that's going to be here, right? So the frequencies are here. This is the frequency of standard policyholders. This is the frequency of premier policyholders. And you can think of these as percent frequencies, right? And the percent frequencies have to add up to 100%. Okay, and then we got one last thing, one last set of inputs to put in, right? Historical data indicates that 16.57% of standard policyholders die within a year. So 16.57% of these are standard policyholders, and they're going to die within a year of purchasing their policies. 8.43% of premier policyholders die within a year of purchasing their policies. Okay, so what we have to do now is, this is the event. The policyholder dies within a year of buying the policy. And this is going to be the expected number of them. This is the total number of people of policyholders that have a standard policy. So the way we calculate that number is we're going to type equals. We're going to multiply the 60.2% times the overall total, right? So we have 109,564 standard policyholders, right? We have 182,000 policyholders. So how many premier policyholders do we have? Well, it's the difference in these two, right? Now, what's the percent of premium policyholders. Now, there's two ways we can get this. We can either subtract the 100% from that, right? Subtract those two. Or we can take this number and divide by the overall total, right? And we get 39.8%. Okay. Now, these two things are marginal probabilities. The marginal probability of standard, the marginal probability of premier, right? This right here is going to be our joint probability distribution. So let's go ahead and start filling this up. The total number of policyholders in our of our customers is 182,000, right? And then we have a total of 72,486 premium customers. And then we have a total of 109,564 standard customers, right? So we're filling in our frequency table, right? Our observed frequency table, correct? Okay, so what else can we fill in? We can calculate the marginal probability of standard, right? And that's 60.02, which is this number here, right? And we can also calculate the probability of premium customers, right? Which is the same thing as this right here, right? Okay. And then this is the sum of these four, right? Or these two, or these two, right? And it equals 1%. Okay. So we got part of our joint probability table filled in. We got part of our frequency table filled in, right? Now, what else can we do? This is the probability of death given that the person is standard customer. So down here, we got two conditional probabilities. This right here is given death, and this is given standard, right? So this is the probability of death given standard. So I'm going to do equals, and I'm going to come up here and grab this probability here, right? Of the standard customers, 16.57% of them will die. So that's the probability of death within a year given standard, right? Now, this right here is the probability of death given premier, right? So I'm going to hit equal sign and go up here. And notice these two things don't add up to 1, right? They add up to 25%. They could add up to 35%. They could add up to 2.5%, right? So do we know this value? Yeah, this value is, we know that these two are going to add up to 1. So this value here is just the difference between this 1 and that value. And then this probability here is just the difference between 1 and that value, right? So again, this is the probability of death given premium. This is the probability of live given premium policyholder. This is the probability of death given standard policyholder, and this is the probability of live given they're a standard policyholder, right? Is there anything else we can do here? Now, this is the expected number of people who will die. And so the expected number of people who die who are standard policyholders is just this probability times that total, right? And then this is the expected number of dying, right? So I can sum these two. So we expect 24,261.1 to die within a year of buying a policy, right? That's what that means. The marginal probability of death then would be what? It would be this divided by the overall total, right? So 0.13333, right? Whoops, sorry. I put that in the wrong spot. This number here is the 24,261. Expected number of policymakers dying within a year of purchasing one of our policies. These are expected values, right? They're not, this is actually not an observed frequency, right? This is an expected frequency. Okay, now this number here is just the difference between that and this, right? So if we expect that many to die, then we expect 157,738.9 to live. One way to get that is to divide those two, or I could just come down here and divide this one and that one, right? Now to get this value here, I can just simply take this value here, the expected number of living. We can divide that by the total number of policymakers, right? And these two things add up to 1. Okay. Now, can we use this information here to compute these joint probabilities here, right? Now, what is this thing right here called? This thing, I'm gonna make it yellow. I'm gonna make this over here yellow, right? Okay, what does this yellow thing equal? The probability of dying within a year of purchasing a policy given the person purchased a standard policy, right? And what does that equal to? Well, that equals the probability of die within a year of purchasing a policy and the person purchased a standard policy divided by the probability that a randomly chosen person bought a standard policy, right? We're just using the definition of the conditional probability. Now I can multiply both sides by the probability of S, right? And I get this. So to calculate the joint probability, I multiply this conditional probability by that marginal probability, right? So this value here is that product, right? So let's go ahead and calculate that. The probability of D given S, this is the probability of D given S, because in the column here, we're holding S constant, right? Right. So that's the probability of D given S. We're going to multiply that by the probability of S, which is right here, right? And we get 0.0998, right? I'm going to get rid of the yellow. Now I can calculate the rest of these, right? So this, the probability of D and P, that's the probability of D given P times the marginal probability of P, right? Now I can divide this by that right here, right? I can divide the probability of L given S times the probability of S, right? Or I could subtract this from that. I get the same thing, correct? So we'll multiply this conditional probability by that conditional probability by this marginal probability, right? So it's the probability of L given P times the probability of P, right? And we'll just double check to make sure that works, right? By doing the difference, right? We should get the same exact number, and we do, right? These are expected frequencies. These are observed frequencies, right? So we can multiply each one of these 4 numbers here by this total here, and we should get these expected frequencies up here, right? So let's do that. Times that, and then this times that. And let's just double check. These two should add up to 24,261. And it does, right? See that? 24,261. And we'll continue doing this. We'll multiply this joint probability times the overall total, and we'll multiply this joint probability times the overall total, right? And we'll double check. These two should add up to that number, and that is the case. These two should add up to that number, which is the case. These two should add up this number, which is the case, right? So all that is good. Now, the last thing we have to do is we have to calculate these conditional probabilities, right? This is the probability of S given D, right? Because we're going in rows. So we're kind of holding the D constant, right? We're only looking at the Ds, the people who die within a year buying a policy, right? So now we're looking at the probability of D, or probability of S given D. So we can either take this and then divide by that, or we can use these frequencies up here, right? We can divide that by this row total, right? Either way it works, right? So I can either do it this way, right? Or I can use values from the probability table. Either way, I get the same number, right? And then I want to do the same thing here. I want to take this probability and divide it by this marginal probability, right? So I got the joint probability divided by the marginal probability. And then what I could do is I could just actually drag this down. And this is going to sum to 1, right? That's going to sum to 1. And the ones down here are going to sum to 1, right? Okay, so I got the frequency table. Well, you call it the observed/expected frequency table. I got the joint probability table where these 4 add up to 1. These 3 add up to 1. These 2 add up to 1, right? So this could be this, it could be the sum of these 2, the sum of those 2, or the sum of those 4, right? And then I got these 2 summing to 1. I got these 2 summing to 1, and I got these 2 summing to 1, and I got these 2 summing to 1. So these are the conditional probabilities, conditional on type of policy purchased, right? This is the conditional probabilities, conditional on outcome of the policyholder, death or continue to live, right? These are joint probabilities. These are marginal probabilities, and these are a second set of marginal probabilities, right? So we've done this several times with raw data, right? And then using a pivot table. All right, we're going to use the probability tables here, right? We have one probability distribution, a second probability distribution, a third probability distribution, a fourth, a fifth, a sixth, and a seventh. We're going to use the 7 probability distributions here to answer the questions over here. What is the probability that a random policyholder has the standard policy? That right there is the probability that a randomly chosen person has a standard policy because it's in the S column, right? We're going to copy that, put it right here. What is the probability that a random policyholder has the premium policy? Well, this is the marginal probability of this column, right? So it's that value. And we can hit enter to make sure that we got the answers correct. And we do. Now we want to answer the question, given a random policyholder has the standard policy, what is the probability the policyholder dies within a year, right? So given standard policy, right? So we're talking about one of these two here, right? And that was the value that was given up here, right? So this right here, we're given standard, right? That's the probability of death given standard policyholder. That's one of the given values. I got to submit. Okay, now given a random policyholder has a standard policy, what is the probability that the policyholder lives? Now, this wasn't given, or was it? This wasn't given up here, right? We had to calculate it. We calculated it by doing what? By subtracting the probability here from 1, right? And that equals 0.8343. 0.8343. Okay. Now, given a random policyholder has premium policy, what is the probability that the policyholder dies within a year? Now, that was a given too, right? That value was given up here. It's one of our inputs to our model, right? So 0.0843, right? Given a random policyholder has the premium policy, the premier policy, what is the probability that a policyholder lives? Now, this wasn't given, right? And we found it by subtracting the thing that was given from 1, right? And we get 0.9157. Now, we know this probability here, right? I figured these probabilities here can be used to answer these two questions, right? But I want to use Bayes' rule to compute it. So what we want to compute here is the probability a random policyholder has a standard policy given the person dies within the year. So this is given the person dies within the year, right? This is the probability of that person having a standard policy, right? Right there, that gray highlighted one. 0.7483. We know that, right? Let's go down here to Bayes' rule and compute it, okay? Now, this is Bayes' rule right here, right? This is the probability of the policyholder having a standard policy given that policyholder died within the year, right? So we have to multiply the probability of standard policy, the probability of a standard policy, which is a given number, right? It was given to us. We're going to multiply that by what? The probability of D given S, right? The probability of D given S, which was given as well too, right? 0.1657. Okay. Now notice that this product here is identical to this product here, right? So all I'm going to do here is I'm just going to do equal and then that, right? So these two numbers are the same, right? You can see that right here, right? These two numbers are the same. Now over here, we got the probability of a premium policy, right? The probability of a premium policy. And that was a given number, right? 0.39. Well, that wasn't really given. We had to calculate it from subtracting this number from 1, right? So this was, we had to compute this number, right? And we want to multiply that by the probability of D given P, right? We want to multiply that by D given P. And that was this 0.843, right? Which is right here, right? Okay, so the first part of Bayes' rule is computing these individual products, and there's 3 of them, right? With 2 of them being the same. The next is to do the arithmetic, right? So I'm dividing this by the sum of these 2 down here in the bottom, right? And I get 0.7483, which is exactly what that is, right? Now, remember what the equation of PS given D is. The numerator is the probability of S and D, correct? The denominator here, right? The denominator, by definition, is probability of D. So these sum to the probability of D. Is that the case? 0.1333. Is that the probability of death, right? Let's go up here. That is the case, right? You see that? 0.1333. So this equals that by definition, right? This gray box equals the ratio of these 2 values here, right? So that must mean that the probability of death is the sum of these 2 here, right? And when we sum those two, we get 0.1333, which is this value here, right? Okay, I just want to point that out. Okay, so we also know this from the table, right? One of the tables above. We want to find the probability a random policyholder has a premium policy. So the probability of P, right? Given the person dies within the year. So given the person dies within the year means we're in this row here, right? So this is the probability of P given D. So we can just use a table value for that number. So let's verify it through Bayes' rule. Now notice in our equation here, we've swapped the S's in the equation with P's. And then where we see S's, we've placed P's, right? So this one value is either here or here. These two values come from there. So we could just recognize that and just do this here, right? We just swap the numbers out, right? This number moves to here and here, and this number comes from there or there, right? We just swap out the numbers. And then I can just copy that for the equation, right? And I get what? 0.2517, right? 0.2517, which is that right there. I'm going to pull this down and put it here. Okay, so this is P given D. So what we do here is we replace the S with P, right? So this, the sum of these two must be the probability of death. And again, that's the case, right? See that? 0.1333. All we did is we commuted the two, right? We used the commutative property of addition and just swapped them. So again, that's the probability of death. And this is the probability of P and D, right? P and D, 0.0336. P and D, 0.0336. This right here is the probability S and D, right? S and D. Probability of S and D. Right there, correct? See how that works? All right. So in order to get these three answers, we're going to fill out this part of the model. To calculate the income of the standard policy, right? We have a total of 109,564 standard policy holders, and each of them paid a premium of $1,350, right? That's the income. Okay, so we're using everybody that purchased the policy, which is in my model 109,564, and we're multiplying that by the premium, right? Which is 147 million, right? 147 million. We do the same thing for the premium policy, right? Whoops, equal. We're going to multiply that by the number of premium policies sold. And we got 184,711, 184,711,800, right? Now we need to calculate the cost, right? To calculate the cost, we have to multiply the number of people who died with a standard insurance premium. We have to multiply that by the benefit, right? The insurance benefit, the benefit that you get, that the deceased gets when they pass, right? Or the deceased estate, right? So we're multiplying by a different number. We're multiplying by the number of people who died with a standard policy. Okay. And then we do the same thing for the premium customer. So that's the benefit, right? The people who die with a premium policy, they get a big payment, $25,600 for a fancy funeral, right? We're going to multiply that by the number of premium customers who we expect to die, right? Okay, and then this is the, I guess, the net income, right? Maybe we'll call this sales, right? That's sales in dollars, and we'll call this income. So we're going to take the sales minus the cost, right? So we lose money on the standard policies, and we make money on the premium policies. And our total income is the sum of these two, right? Okay, so let's do that. So the expected loss on the standard policies is what? It's negative, so it's a loss. $15,662,940.75. And we're going to round to 0 decimal places, right? So that'd be a 1. Right? So that should work. Okay, that works. Good. What is the expected income or loss on the premium policies, right? So on the premium policies, notice I didn't enter any dollar signs. Right? On the premium policies, we're making $28 million, $389,117.12. 12 cents rounds to $0, right? So that should do it there. Okay, then we need the total income, right? So when we add those two together, we get $12 million here. 12,726,176.37. 37 cents rounds to $0. So that's where we stop.